Hello guys, this is Paul McWhorter with TopTechBoy.com coming to you today from the shores of the mighty River Nile in order to bring you episode number 9 in our incredible new tutorial series where you are learning how to make Arduino and Python work together. Now what I'm going to need you to do is I'm going to need you to pour yourself a nice strong glass of iced coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what we're going to do is we're going to look at my solution to the homework assignment that I gave you in lesson number 8. Now, if you remember, we have been using the most excellent DHT11 temperature and humidity sensor connected to an Arduino. We are passing the temperature and humidity data over to Python, and then in Python we created a nice temperature graphic to show like a 3D model of a thermometer that updated in real time, displaying what the real world temperature was. And then what your assignment today was, your assignment was to go in and now add some sort of visual to indicate what the humidity is. How many of you guys were able to do this? If you were able to do it, comment down below. I am legend. And those of you who weren't can simply say I folded up like a cheap Walmart lawn chair. Okay. But in any case, I hope you guys that did get a solution, I hope you guys will continue to post your solutions to YouTube. And then in a comment down below, put a link over to your homework solution. And then also in your video, put a link back to this video so people sort of that stumble on it will kind of know what the context is. But what is kind of neat is if we sort of see how other people have done it and who comes up with the most crazy, bodacious solutions to this thing. Okay, now what I want to do is I want to actually jump in now and start showing you my solution. But before we open up Visual Studio and start coding, we really need to get it working on paper, because when you have something as complicated as like the strategy that I'm going to take is to have a meter, sort of like our voltmeter, and have the dial on that meter show humidity. When we're going to do something like this, you can't just jump in and start coding. You've got to sketch it out and lay out a strategy for solving the problem on paper. And if you do it on paper first, it's really easy to do it in code. When I was teaching people live in person, the number one mistake that I would see them make is they would jump in and start coding before they had a clear idea and a clear strategy of how to do it. So what we're going to do is we're going to do it on paper, and we're going to do the math, and then the coding will be relatively easy. Does that sound good? I sure hope it does. So what we're going to do is we're going to switch over here, and I am going to get out of your way, and we're going to talk a little bit about how we are going to do it. Well, first of all, let's jump in and just remember where we ended up last week. Where we ended up last week is we had a thermometer, okay? And that thermometer was about 6 inches tall. And so what we're going to do is if we just come in and we just start building a humidity sensor like this, it's going to appear right on top of the thermometer. So right off the bat, we've got to sort of realize we've got to build into this like a Y offset. Okay, we have got to build into it a Y offset. So right off the bat, I think that I want to think in terms of the dimension. Okay, and let me start drawing in purple so you can see this, that the dimension, I'll call this box X, and then I need a dimension here, and I'm going to call that box Y. And then on the arrow, I'm going to have an arrow length. Okay, and then I'm also going to have an arrow thickness. Okay, and so I want to kind of lay these things out. Now, what the values are, we can tweak those values, but the thing is, as we start building our model, we need to put it in terms of these parameters that we're defining, and put everything in terms of parameters, and not just jump in and start putting numbers in our model. We want to base it on these parameters. Okay, what other things do we need? Well, I think we should also, very important, I think that we should just build in right off the bat. We've got to think in terms of this is going to have some X offset. It's going to have some X offset. And I think it might be centered up well enough that we really don't need a Y offset. All right, now that is going to be the basic parameters that we're going to need. I think we're going to need a box X, we're going to need a box Y dimension, we're going to need to have some offset that we're moving it over, and then we are going to need to have some arrow length, and we're going to need to have some arrow thickness. And those are going to be kind of the primary parameters that we are going to be using to get this thing started. I'm going to go ahead and clear that out and say then the next thing that we are going to need to think about is how our meter is going to look. And we go back to our friend, the unit circle, and what I could see is I really like my meters to go from the 5 pi over 6 position to the pi over 6 position, and this would be the range of motion. All right, now we've kind of got into how do we make this thing work. Well, when it's over here at the 5 pi over 6, when it's over here at the 5 pi over 6, right, the 5 pi over 6, that would correspond to what? 0 humidity. Now, what is the independent and what is the dependent variable? What number do we have? We have humidity. Okay, so when the humidity is 0, what do I want the position of my arrow to be, or my needle to be? I want it to be at 5 pi over 6, because that is the left position over here. And then, what is my highest relative humidity? That would be 100 or 100%. And I want that to come all the way over here to 5 pi over 6, or all the way over, to pi over 6. So now I have 2 points. I've got my first point, I've got my second point. And just to kind of help you remember with the math, this is the point x1, y1. So you could think of this as x1, y1. And then my second point is x2, comma, y2, like that. Now what do I need? I need an equation for a line that will smoothly take me from angles of 5 pi over 6 over to angles of pi over 6. Well, how do we do that? Well, we calculate the slope. How do I find the slope? M is equal to y2 minus y1 over x2 minus x1. Okay, what is y2? You can see it up there. That is pi over 6 minus y1 is 5 pi over 6. And all of that is going to be divided by what? 100, which is x2, minus x1, which is 0. All right. Now, what does that come out to? Pi over 6 minus 5 pi over 6 is minus 4 pi over 6, and that whole thing divided by 100. Now that is going to be equal to, the 6 and the 100 are both in the denominator, so that's minus 4 pi over 600. And we are going to be good boys and girls, and we are going to reduce our fractions, and so that is going to be I can take a 2 out of both, so that's minus 2 pi over 300, which is equal to minus pi over 150. So the slope m is equal to minus pi divided by 150. Okay, now we want the equation of the line. What is the equation of the line? Y minus y1 is equal to m onto x minus x1. All right, now what we have to see is we have these. The x1 is up here, and the y1 is up here. So we can just go in and we can put those in. And so what I'm going to say is y minus y1, which is what? 5 pi over 6 is equal to m. And what is m? Minus pi over 150 times x minus x1, which is 0. Okay, so now y is going to be equal to minus 5 pi over I shouldn't have done that. I'll try again. Y minus 5 pi over 6 is equal to minus pi over 150 times x. Now, what do we just need to do? We need to add 5 pi over 6 to both sides of the equation, and then we have y is equal to minus pi over 150 times x plus 5 pi over 6. All right, now we just need to go in and rewrite it in terms of the variables that we have. Okay, and what are the variables that we have? Well, the x value is what we start with, which is what? Humidity. And the y value is what we want, which is what? Theta. Okay, and so now how can we write this? We can write our final solution up here as what? Theta is our y. Theta is equal to minus pi over 150 times the humidity plus 5 pi over 6. And now that will be how we take the humidity that we have and we turn it into the angle that we want to point our pen. Okay, so what I need you to do is, I think that is kind of like the setup. And this equation is going to make this whole thing very easy. And this strategy is going to make this whole thing very easy. And so what we're going to need to do now is just begin to code. Now I'm going to come in here and look at this and make sure that that is in fact what I had ended up with. And let's see. I just want to check my math here before I go on. Yeah, I think that's good. That is good. Okay, so are you guys starting to see the magic of math? It's like always in math, you hated it because what did they call it? It's like they always called it math problems, right? Math is not problems, math is solutions. And if you tried to go in and solve this needle problem using 100 if statements, you would be pulling your hair out. And this math is going to make it so much easier. Okay, so let me look here and come over here to my code view, which I believe is right here. And now just as a reminder, it was in lesson number 7 and 8 that we coded up the Arduino and we set up the DHT11. So we're not going to go back and do that again. But what we are going to do is we are going to fire up our most excellent Visual Studio Code. We are going to come over here, and just a reminder, we are working in this Pi Arduino folder, and I am going to create a new program, and that is going to be pass data -6. We're on -6 already. I can't believe that. .pi. Okay. Now the one thing I will say is that we don't want to start completely from scratch. We want to start with that temperature graphic that we already had. Last week we were pulling the data over, the temperature and humidity data we were pulling over, and then we were showing the temperature part, and then today we're going to get the humidity part going. And so what you can do is you can fire up a browser. And on that browser, you can go to the most excellent www.toptechboy.com, and then you can search on using Arduino with Python Lesson 8 Live Thermometer 3D Visual, or you guys might already have it from before. Now, I'm not going to reprogram the Arduino because we've done that twice already. The Arduino already has the code in it. But over here on the Python side, I'm going to grab this code, and then we're going to come over here and paste it like that. And now just to make sure, let's see, this is better. Just to make sure that the universe is operating as we expect, what we're going to do is we are going to run this. I'm going to get the File Explorer out of the way. So let's go ahead and run this and see what happens. It should pop up and give us our thermometer if I'm thinking right. Okay, that looks good. 80.42 degrees, that's about right. And we have just an excellent visual here, an absolutely excellent visual. So what we are going to need to do is now we are going to need to come in here, and what we are going to need to do is we're going to need to start putting in the code that will allow this to then become, not only the temperature sensor, but also to have that, to also have the humidity sensor. Okay, so we get the data here. You can see that we've got the data we've got set up our serial port to bring the data in. And then right here, we start working on the thermometer. And so before we do the thermometer, I am going to come in, I'm going to start working on the humidity sensor. And so the first thing that I think I will do is, remember we had a box X, and I'm trying to think, since the humidity or the temperature sensor was 6 high, I think I want the temperature sensor was 6 high. I think I want the humidity sensor. I'm going to start with it 10 wide. Okay. And then if it's 10 wide, then the box Y, how tall is it? I'm going to make it 6, which is about the same height as the thermometer was. All right. And we can change all of this. Now it also needs to have a little thickness. So the box Z is going to be equal to just 0.4, something really, really small. Now, how far do I want to move it to the right? Okay. Well, if it's 10, its center is going to be lined up with the center of the thermometer. If I move it 5, the edge is going to still be in the middle of the thermometer, so I need to move it more than half. And so I'm going to say the offset right. I think that the offset right should be the box Y, or the box X, how wide it is, divided by 2, so now it would just be overlapping. But now I need to probably add 2 to that, and that way when it scoots it, the edge won't be over the thermometer. Does that make sense? I hope that makes sense. Okay, now let's make the case. Let's make that plate that everything's going to be built on. So I'm going to say my case, and that's going to be equal to a box, and the size box, and the size is going to be equal to a vector, right? And how big should it be? Well, it's going to be easy. Box X, comma, box Y, comma, box Z, like that. Now, what's the nice thing? Later, if we want to adjust it, we don't have to come back into this command. We can just do it by changing our parameters. Now on color, I want color is equal to color.white. Okay. And now we are going to need a position. Okay. Like, where are we going to put this thing? What is its position going to be? Its position is going to be scooted over, offset. That's not how I did it. Offset right. Okay. Its position is going to be offset right. And then also, if you think about it, it's going to put the bottom at the center. I want to pull the whole thing down so that the center of the case is sort of aligned with the center of the thermometer. And so I want to move it down, so I'm going to move the whole thing down by box y divided by 2. That will put the center of my case lined up with the center of the thermometer, more or less. And then also, what I'm going to need to do is I'm going to need to give it a thickness. Okay, I'm going to need to give it a thickness offset. I want to offset it back. Okay, I want to push it back into the screen, and that would be the negative z direction, and I want to push it back by box z divided by 2, and that way everything's going to kind of be floating, either touching or floating above the box. It's not going to be in the middle of the box, if that makes sense. Okay, and then what we need to do is, what is it not like about that? Position is equal to vector, as we know. All right, I think this might should go ahead and show us a visual. So let's just see if it's more or less a box in the right spot. Okay. What I do not like is I do not like that I set that thing down. That does not look right at all, does it? We did not want to scoot that down, because I guess it does normalize a box to the center point and not to the edge. And so I was wrong on that, but that's okay. We will come in here and we will fix that really, really easily by coming back to my case, and then where I offset it down, I was thinking it was aligning to the edge. I will just put that as a 0, and then I think that should work. So let's go ahead and see what happens there. Okay, I think that looks really good, right? I mean, I think that's looking good. I can see the thermometer clearly, and then I'm going to have a nice big humidity sensor. So I think that is good for us to kind of go with at this point. So now we have the case set up just like we want, and then what we need to do is now we need to start working on our arrow, our needle. But I'll call it arrow just because I think that's easier. But I think of it in terms of a needle. So I'm going to say the arrow length, right? And now if the box is 6 tall, we don't want the arrow to be that long. And so I think that the arrows should be the box Y. And then let's see, let's just say -2, okay? And that way, if we change the box size, the arrow size here should respond to that. And so I think that would be pretty good. Okay, and now let's get an arrow thickness, and I'm just going to say that's 0.15. What else do we need? We're going to create the arrow now. My arrow is equal to the arrow object. And then what all am I going to need? I'm going to need the length, and that should be equal. That should be easy because we've set that up as arrow length. Arrow length. Okay. And then we are going to need a color equal color dot red. And then we are going to need a shaft width. I think it's shaft width, all lowercase shaft width. Let me move that up. Shaft width is going to be equal to, why does that not want to go there? Shaft width is going to be equal to what we called arrow thickness. Okay. And now we got to give it a position. So the position is going to be equal to the vector. And then where are we going to want this thing? Well, first of all, like everything else, we have to move it in X offset right. So we're going to move it over what we're moving everything over by. And now what you have to see is the arrow is going to need to be moved down. Okay, because if you just put it it's going to be in the middle of the box, and then it would be moving outside the box. You want it down at the bottom of the box. So we would need to move the arrow down. Down is negative by what? Box y divided by 2. Okay, but now the problem is if we did that, it would put the base of the arrow right exactly on the edge of the box, and that's moving it down too far. You want it up a little bit. So what we could just say is go like 90%. So we could take this whole thing and say times, we could say 0.9 times that. And now it's going to be down almost to the bottom, but not quite to the bottom. And then we got to make sure that we remember that we do have to put in a z, and we're just going to put in, for the z, we want it up a little bit. We want it floating above the case. We don't want it scraping on the case, so we would want to move it up just a little bit. And so I'm just going to say 0.25. Probably would have been good to make that a parameter. Yeah, let's make it a parameter. So we're going to say arrow z off, like that. And we're just going to say that is going to be equal to 0.25, like that. And that way it'll be a little bit more than what its thickness is. And so then here we can come back over here, and instead of this we can say arrow z, that was terrible, arrow z off, like that. I think we should run this now, and we should see an arrow in the box. Got to kill the other program first. Okay, that looks pretty good. Now don't worry that that looks a little bit close to the bottom. It looks a little bit close to the bottom, but let's just go with it, because remember, it's going to be swinging up, and it's not going to start all the way down at the 0 angle. It's going to start over here at 5 pi over 6 and go to pi over 6. So let's just kind of go with this and not panic about it just yet. Let's not panic about it just yet, because we can always come in after we've built a little bit more on it, and we can add some more parameters to it. And so now we could go and put our tick marks. Let's see if we can make this thing live yet. I want to go ahead and see if I can make this thing live. So what if I said my arrow dot axis, okay, we got to calculate the theta, and remember we had the equation for that. Okay, let me come back over here and fire up that equation again. And I'll come back. Okay, so you see it's that up at the top, theta is minus pi over 150 times humidity plus 5 pi over 6. So that is what we are going for. And so we are going to calculate theta is equal to np dot pi. Remember, and if we're going to use NP, we better import NP up here. So I'm going to say import numpy as NP. Remember, numpy is the library that allows us to do the trigonometry functions as well as a bunch of other stuff. So it's going to be NP times pi divided by 150, okay, times what? Times the humidity, HUM, because that's what we called it here last week when we brought it in, okay, and then plus 5 times NP dot pi divided by 6. And let's just come back over here and check that. Okay, yep, its theta is minus pi over 150 times hum plus 5 pi over 6. And so that indeed does look really good. Okay, this might actually, now what do I need to do? I need to take that theta and I need to say my arrow dot axis. And remember how we go from an angle to the position of the tip? The x value is what? The length of the vector times the cosine of the angle, and the y is the length of the vector times the sine of the angle. And so we can do that really, really, really easy. What is the length of our vector? It is arrow length, okay, and then times what? Times np dot cosine. So our friend np is helping us again, times cosine of theta, okay, and then comma, arrow length times np dot what? np dot, get my head out of the way. How about that? You like that? That's the super small version of me. np dot sine of theta, and then comma 0, right? Because in z, right, you don't want it going anywhere in z. Okay, so I'm going to come back to more of an acceptable size, and now let's see if we can run this and see what's going to happen. Nothing. What did we do wrong? Okay, first thing to do is see, because I would have expected that to actually come to life. Let's see, we probably got an error. And let's see. What does it not like? My arrow dot axis. Oh, I do that again. Equal vector. In the old VPython, the format was a little different, and so I'm still trying to kind of go back to the old way of doing it, but let's try again. Still not alive. All right, so let's see. Do you guys see what my error was? So let's look. It seems to be here. It's not vector size. What is that? That is crazy. What did I do? My arrow dot axis is equal to vector, okay, and then arrow length times np cosine theta, arrow length times np sine theta. I don't know where that came from of what I just did. I don't know where that came from. We got some wrong math in there, guys. We got some wrong math in there. So let's see what we did wrong. Maybe we calculated theta wrong. Theta was supposed to be, you guys, did you see? Come back over here. What did I do wrong in my theta? What was up here? What was up here that I didn't put in? I didn't put in the negative. And that is what happened. So we're going to come back over here. Okay. And we're going to put in the negative. And now let's see if it likes it anymore. Negative np pi over 150 times humidity times 5 pi over 6. Let's see if it likes it now. Still not happy. Minus np pi over 150. That sure looks right. Okay, okay. Now, what is our relative humidity? Am I printing that out? No, I'm not, but it is about 60% out there. And so that actually looks roughly in the right spot. So I think we've got the hard part done. We've got the things live. Now we just got to go in and we need to dress it up a little bit. And so how will we dress that up a little bit? Well, we're up here. We've got the arrow made and the arrow is live. And so now what we need to do is we need to come in and we need to put some tick marks on it. So I'm going to give it some parameters. I'm going to say I'm going to have a tick length, and that's going to be, let's make it 0.25. I'm going to have a tick width, and let's make that 0.1. And I'm going to have a tick height, and let's make that 0.1. And so I'm kind of defining those tick marks that I'm going to put over there. I'll compromise. I'll get sort of medium small. You see, I've got the big me. I've got my preferred size. Then I have the medium small, and then I have the extra small. All right, so we're going to come back to, we'll go to this one. All right, so I've got the tick tick length, tick width, tick height, and now I've got to go in and let's put in the major tick marks. So I'm going to say 4. I'm going to say 4 theta, that's the angle, okay, in np.len space, and remember that we go start value, stop value, and how many steps. And where do we want to start? We want to start at pi over 6. I'm going to go np.pi divided by 6. Really, to be perfectly honest, if we go in the right order, we start at 5 pi over 6. So let's do that. 5 times np dot pi divided by 6. Where do we want to go to? We want to go to np dot pi divided by 6. And remember, I showed you the unit circle. That's where that came from. And then how many steps do we want to go? Well, I want to kind of go relative humidity of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, but since I start at 0 and go to 100, that's not 10, that's 11. All right, and that's always because you're starting at 0. And so that will be like that. And now I've just got to go in and I've got to give those tick marks a position and an axis. So what I'm going to do is I'm going to say tick major. The tick majors are going to be equal to a box. And now it's just getting those sines and cosines in there. So I'm going to say arrow length times np dot cosine of theta, just like we did below. Okay, and then that's the x value. Then what is the y value? Arrow length times np dot sine of theta. And even there, my head's getting in your way. Okay, np sine of theta. And then what do I want? I want the z value to be 0. All right. And I needed something else in there. That was a tick major. That is going to be the position is equal to the vector. Okay, so the position is going to be the vector arrow length times np cosine theta, arrow length times np sine theta, and then 0. All right, so that is the position, right? Does that make sense? That is the position. Now, what I also need to do is I need to give it a size. So then I'm going to say size is going to be equal to the vector, and then this is going to be the tick length, the tick width, and the tick height, like that. Okay, now what else am I going to need? I'm also going to need the color. So I'm going to put a comma, color is equal to color dot black. And now I'm still going to need, even now, I'm going to need to put the axis in, right? Because if I don't put the axis in, it's going to have them in the right spot, but they're not going to be pointed right. But the good thing is they're pointing just like their position is. It's the same vector. So I can get this vector. I can get this vector that we just defined, and that is going to be the same. So I will copy that, and then I will come over here and I will say my axis is equal to vector, and then I'm going to put that vector in, Control V, I'm going to paste that vector in, and I had got an extra vector there. And axis does have an X in it. All right. And so this closes the vector, and that closes the command. Okay, so let's see if that's going to work and put those tick marks on it. Okay, so here they are. What did we forget to do? We forgot the what? We forgot the X offset when we put those vectors on there. Okay, when we put those tick marks on there, we forgot to offset them. So now I think they're probably doing kind of the right thing. They are just in the wrong spot. And so let's go in and let's fix that. So that would be coming back over here. We've got to put in those offsets, and we got to think about what they are. Now the offsets you don't put on the angles, the offsets you just put on the position. So in the X value, what do I need to do on the X value? I need to add to it offset right, right? We were supposed to do that to everything, offset right. All right. Now also we need to bring them down. Okay, we need to bring them down because otherwise they're going to be up at the top of the box. And so we need to bring them down by y divided by 2. Okay, and so that was the X, and now we need to bring them down minus box y divided by 2. Now, why is that? Because they are being referenced to the center of the box, and so they're going to be too high. We need to reference them to the bottom of the box, but more specifically, we need to reference them to where we put the needle. And so that was not moved down by box divided by 2. It was 0.9 times box divided by 2. And so that goes back to this arrow command. And remember, we moved the arrow down that much, and so the tick marks have to come down by that much as well. All right, and since we already did this on the voltmeter, I think that this is the second time you've seen it. All right, that looks good. Now, what's the one thing that we don't like too much? What is the one thing that we don't like too much? I think that my tick marks need to be longer. And then also, well, let me just try making the tick marks longer and see how that does it. And so the tick length I have at 0.25. I want to make that more like 0.4. Let's see how that looks. And then we're going to have to decide whether we want the needle going over the tick marks or not. Okay, so you see the nice thing is now we're just tweaking the parameters, and those hard commands are in there working, and we're just tweaking the parameters. Okay, I don't like that's going too far over that tick mark, I think. And so I'm going to move the tick marks a little bit further out. I'm going to move the tick marks a little bit further out. Well, how would I do that? That would be on the tick marks on their position. Okay, and so what I'm going to do is I'm going to move them a little bit further out by saying 1.1 times the arrow length and 1.1 times the arrow length. And so that's going to just scoot them all out a little bit. And let's see how that looks. What did it not like? Okay, I really like that. What do you guys think? Let's also sort of see how we've got the alignment. Okay, see, what I like is the tick marks are physically connected to the base, and the needle is floating above. And so that kind of like, you sort of have your basic physics right there. I don't like things that are overlapping where they shouldn't be. Okay, so now if we've got the tick major, we also are going to want the tick minor. And so to do the tick minor, I'm just going to control copy the tick majors. Okay, and it'll be almost the same. So now what I'm going to do is here, instead of tick major, these are going to be tick minors. Okay, tick minors. And in this case, what is going to be different on the tick minors? Well, one thing is we are going to go from 5 pi over 6 to pi over 6, but instead of having 11, okay, what you have to think is instead of having 11, I'm having to think, yeah, you're going to want to have how many? Well, I'm going to want, like, I don't want to do let's try going in 0.2s. And so if we went in clicks of 2%, then that would be a total of how many? That would be a total of 50 to go from 0 to 100, but we've got to remember we're starting at 0, and so it would actually be 51. And then I think on the how do we make them a little bit smaller? We have to think about how to make them a little bit smaller. So let's make them like 70%. Let's make them on size. Let's make them 70% what the others are. And so we'll come here and we will say, let's put tick factor here. So we'll say it's tick factor times tick length, and then tick factor times tick width, and then tick factor times tick height. And then let's come up here, and then we will define tick factor, and let's just make it 0.7 times what the other ones are. So these are going to be smaller tick marks. Okay, so now let's run this, and we should have the minor tick marks in here. No minor tick marks. What did we do wrong? Okay, we probably have an error. So tick minors are 1.1. Oh, tick F. Misspelled tick. Hopefully you guys saw that. Okay, let's come in. Okay, now that's kind of neat. Let's look over here. I have 10, 20, 30, 40, 50. So the relative humidity looks like it's about 60. Okay. And that looks kind of nice. I think I like those tick marks like that. My needle is a little bit hefty. I want to make my needle a little bit smaller. Okay, I want to make my needle a little bit smaller. Okay, so my needle up here would be my arrow thickness. And where did we do that? Arrow thickness, I'm going to make it just 0.1, like that. Arrow thickness is going to be 0.1. And I'm going to make the ticks a little bit smaller as well. Like I'm going to make them 0.07 and 0.07. They were a little clunky as well. You guys can adjust yours however you like it. I just think they were a little bit clunky. Okay, I am just not having luck typing today. Okay. .07. Okay, now let's see what happens. Okay, I kind of like that. All right, I think that's looking good. Now let's go in and let's put our numbers on there, our labels, and that will be the next thing that we do, and that should be, that killed my Visual Studio. Okay, that should be fairly straightforward. So what I will want to do here is now we're going to come in and we're going to put our labels in. And so again, we're going to go for theta, and the theta is going to be in np.linspace. And again, where do we start? We start at 5 times np.pi divided by 6, and we go to np, that's 5 times np pi divided by 6. And then where we want to go to, we want to go to np.pi divided by 6. And now how many do we want? Well, again, we want 11, because if we're going to go from 0 to 100 and we want 10, 0, 10, 20, 30, up to 100, that's 11 labels, because you got to count 0. So that's going to be 11. And then what is it going to be? Well, the label is going to be equal to a text object. The label is going to be equal to a text object. And now what is the text? The text is going to be equal to, well, it is going to be equal to what would be the easiest way to do this? We're going to have to set up a number up here. We're going to have to set up a counter because it doesn't really have anything to do with theta. So we're going to come here and we're going to set a number, which is just going to be a counter. It's going to start at 0, okay? And then the text is going to be the string value of our number. Okay, it's going to be the string value of our number, and then every time through, the num is going to be equal to the num plus 10. Okay, and now we just present it as that. So it's going to be 0, 10 all the way up. So that should work. We're going to increment num by 10. And now the label should be right. And now we've got to put in a position. So our position is going to be equal to vector. And the vector is going to be almost the same. It's going to be almost the same as the major tick. Okay, it's going to be almost the same as the major tick. So we're just going to grab that. Okay, so we're going to put it just like we did the major tick, right? But if we do it exactly the same, then the number is going to be on top of the tick. So we better make this a little bit bigger. Instead of 1.1, it needs to be 1.2, and that'll scoot it out further, right? That'll scoot it out further. So now we have the position. Now the axis should be exactly the same. The axis should be exactly the same as this. And so we'll just borrow that axis state. That axis, we'll just borrow the whole axis, because we want that angle of the label to be the same as the angle of the tick mark. So now we are back here in our label command, and we'll put it in there. Okay. And now we probably need to give it a color out here. So we will say color equal color dot what? Black, probably. All right. And now the final thing that we need to do there is, I think that we need to probably give it a height, right? We need to give it a height so that we kind of are giving it some sense of a text size. And so we're going to come here and we're going to say height equal 0.4. And then we also need to say align is equal to center. And that way it'll be centered up right on that tick mark. Like that. Okay, let's run this and see what happens. Boom, look at that. Okay, now what do we have? We've got everything kind of lined up right, but we need to, it looks like on our axis, it looks like we need to add pi over 2 to flip them on around. Okay, to flip them on around, we need to on the axis. Okay, on the axis for the label, we need to add plus np dot pi divided by 2. Now you guys see it, I'm adding it to the angle. Plus np dot pi over 2, because it's referenced like this way, not this way, so I've got to kind of rotate it, and then everything else should work. I think this should work. Let's take a look. Either that or I needed to subtract np pi over 2. We'll see. Probably I should have, I probably should have more formally thought about it, but it's either going to be np pi over 2 or minus np pi over 2. And in fact, it looks like it should have been minus np pi over 2. And so we'll come back over here and we're going to subtract np pi over 2. Subtract np pi over 2. And also it seemed like that length probably needs to be more like 1.3 and 1.3 on the position to scoot them on out further. All right, let's take a look now. Yeah, I lied. 1.3 is too far. We'll go to the 1.2. And I'm on the label command there. The 1.2 was right. I think this one's going to really look good. I think this is going to be very, very close to what we need. Okay, let's take a look. Running it here. Boom! I think that is just absolutely perfect. Okay, looking in 3D, you see how it's connected to the base as you want. And then the needle should be, needle is floating a little bit above. That is really slick. Hey, I think that looks really good. Okay, now I want to just run this, and then I want you to tell me a few things you don't like, and you're going to learn a few new things now. Now, I know on those axis commands, I went through it kind of quickly, but if you guys are confused, go back and look at, I don't know if it was lesson 4 or 5 or 6, where I showed you how to do the voltmeter, and on the voltmeter, I built this thing, and if you went through that lesson, then I don't need to quite go into so much detail on this one. But let's look at this and let's see what we don't like, okay? Let's see what we don't like. Okay, remember how we built the thermometer in the middle, and then we moved the meter off to the side? And so, wow, that's great, but what is wrong? We have all this black space over here. Now, what you might see is we have one option, and that would be go into every single command in this program, and that's a position, and move the position to the left by kind of like half the size of the thermometer plus the size of the humidity sensor, and take that divided by 2 and offset everything to the left by that amount. And that you could do it. Or the simpler thing that you could do is we could just move the camera. Okay, so let me show you just how to move the camera, because that is a neat thing that you could use in a lot of different cases. And so let's come up and let's move that camera. And so the way we're going to do that is we're going to come up here before we do any of this other stuff, but we're going to go ahead and set up our serial port. But before we do anything else, then what we are going to do is I am going to say the scene.center. Where is the scene of the center? It is equal to a vector. And then what do I want to do? I want to move the instead of moving the scene to the left, I want to move the camera to the right. And I want to move the camera to the right by, let's say, 5, okay, and then 0, 0. I don't want to move the camera up. I don't want to move the camera down. I just want to move the camera to the right by 5. And let's see what that does. I think that's going to work. What did that not like? Now that is most unusual. Really don't know what happened there. Okay, let's try it. Let's try it again. Let me kill it. For some reason, it like opened up a completely new browser, and so not sure why it did that. It did it again, so I'm just going to have to move it over here where you can see it like that. And then I will move it here. Okay, boom, look at that. Do you see how much nicer that is? That fills it in really, really, really nicely. Okay, now what is one thing that I would really like is I would like to be able to make my scene bigger. Okay, because you see if I want to zoom in all of a sudden really quickly, I lose it. So how would I make my scene bigger? Not the elements bigger, but make the scene bigger. And the way I could make the scene bigger is I could come up here, and right there where I did this scene, I could also say scene.width is equal to, let's make it 1,000 pixels, and the scene.height is equal to, let's make it 600. Okay. And then I think that if we do that, we're going to have a little bit more room to work with. And so let's see if that makes it bigger. Boom, look at that. You see it made the scene bigger, and now the whole thing, it's just sort of like it scaled the whole thing up when we did that. And now we can move it around and look at things, and oh wow. And guys, again, I'm not going to try to be a hero and like put a match on my sensor or put something on it, because it's like a match will melt it, ice will short it out. If I breathe on it to try to heat it up, then that can lead to condensation on it. But you guys can kind of do what you want. But man, look at that. That is really cool. What's the one thing we don't like? When we move the camera over, it didn't move the 81.32, but it's like the 81.32 is over here. And when I move my face over here, now it's like the 80.1.32 is not in the right spot. And so what was that? What was that? That was, what was that? That was, we got to get down in here. The dig value is a label. Yeah, I think that's it. And the position vector was 0, and then minus 2.5 would have moved it down. And so I think I want to move it to the right by, let's just see if I move it to the right by 0.5 on that label. Let's see if that will bring it back my direction a little bit. That did it some. I probably need to go like 1.5. Nothing like a little trial and error here. But really, trial and error is okay on this one because, right, this is a label. It's not a three-dimensional object. Too far. Okay, so what do you think? 1? Like that. Okay, guys. Wow. All right, we got it. Okay, man, I hope you guys are having as much fun taking these classes as I am making the classes. I don't think I need to be that small there. I'll leave a little bit of the view of the pretty river there. But man, I felt like this lesson was a little bit tedious. And I was going fast because I knew I needed to cover a lot of stuff, but I did not feel like I needed to go in and explain every single little step as much as I had before. If you need to understand this better, go back and watch that live voltage graphic that we created, because it's kind of like the same math and the same orientation. It'll help you understand exactly how all of these things, all these things came into place and came into being. But you see, a lot of times, the reason I've done this twice is a lot of the displays that you would want to do when you're making real simulations, when you're connected to the Arduino, you either want kind of like a bar graph or you want a dial. And the dial is not that complicated. If you just remember, the X value is the length of the needle times the cosine of the angle, and the Y is the length of the needle times the sine of the angle. And then you'll get not only the position right, you'll get the pointing right. It's just like everything depends on that simple little cosine value for X and that simple little sine value for Y, and that will make your positions work right, and that will make your axes work right. And so I hope now that you've had a chance to see that a few times, I hope it is making sense. Okay. What is your homework for next week? Your homework is to just go in and just really dress this thing up. Okay. Next week, I will be moving to a kind of a new topic with more learning. But what I want you guys to do is I want you guys to really dress this up, add more annotations, make it look more real, thermometer look more real, the humidity sensor look more real. I want you to really, really dress it up, and that is your homework for next week. Now, what I am thinking that I will do next week is I will probably be thinking of a way to show you how to begin to pass data back from Python to Arduino. So Arduino, right now, Arduino's talking and Python's listening, okay? But right now, Arduino is not a very good listener. So what we're going to do is show you how you can send data from Python to Arduino and then from Arduino to Python. And then that is going to open up just a huge, huge new array of things that we can do. And so again, what my goal is, as we're moving forward, to start doing more and more complex things on the Arduino side, as far as the project, as far as the components and what we're doing on Arduino, and then on the Python side, doing more and more complex visualizations on the Python side. Okay, guys, remember to post your homework solutions to YouTube. Leave a comment down below pointing over to your homework solutions, and then look at other people's homework solutions. Let's see how different people are doing this, and let's just see who can come up with the most crazy, insane graphic for their thermometer and their humidity sensor. Okay, guys, been a little bit of a tedious lesson, been a little bit of a long lesson, but I think we ended up with a most excellent result, and hope you guys are happy. Paul McWhorter, sitting on the banks of the mighty River Nile. I will talk to you guys later.